Take 3, this time with the laser pointer turned on. How are you all? The anode is negative on a battery. Well, the sky is falling. All your colleagues are laughing at you. You're a techo. What's all this about? Let's have a look. Well, we've got a definition here. I call it the anode rule. Electrons always flow out of an anode. Now, there's 2 important things there. First of all, we don't talk about voltage whatsoever with an anode. We only talk about current. I'm an old techo, and from my point of view, the anode was always positive for a few reasons. So, but with batteries, it's usually negative. It's always negative. The anode's negative because electrons have to flow out of the anode. Let's keep going. Now, to show you how voltage is really an unreliable indicator of current flow or current direction, have a look at this. You got 2 wires here, 2 wires here. The current's flowing in the same direction in both, but the voltage has been reversed here, and yet the current's flowing in the same directions. How can that be? Well, we can account for the negative voltage here because there's a negative on this battery here. That makes sense. And it's probably going to go through a load and back. Electrons going this way. No problem. So the electrons are still going this way, but the voltage is reversed. So what have we done here? Have I been sneaky? Have I been tricky? Have I tricked you? Yeah, I have. So we've interchanged the resistor and the battery, and we've turned the battery upside down. So the positive here we can account for that by the fact that we've got the positive terminal of the battery connected straight to that voltmeter. Electrons leave the negative terminal of the battery, move around here, and they go through here. So positive battery, positive top, negative battery, negative top. But in both cases, current going from left to right. I want to make one point here. I could have made this whole video and my anode rule would have just been that the conventional current flows into the anode, and that would have been just as easy. But I'm going to pick electrons because there's only 2 or 3 components, and even for an old tech that uses conventional current flow, I'm sure I can get through the next few minutes just thinking about electrons going from negative to positive. So anyway, this slide's showing you that you can't tell if electrons are going in or out based on voltage. You swap the voltage around and the current's still going in the same direction. So that's not a good indicator. Let's look at some passive components. Okay, I've picked an LED, a light emitting diode. It's got an anode, it's got a cathode. And this is what we've grown up with as techs, positive on the anode. But does it comply with that definition? Yes. Electrons flow out of the anode. There's the anode. Electrons are flowing out. Electrons being negatively charged, they want to get to that positive plate of that battery. And this voltmeter picks up the positive. So everything there looks good. Nothing to see there. We call them valves in Australia. Americans call them vacuum tubes. Vacuum tube, but whatever. They've got a plate here, which we call an anode. Some of the older tubes, 6CM5 and things like that, if you're a TV tech, had a anode cap, and you better be very careful you didn't put your finger on that because it was many hundreds of volts. And why am I telling you that? Well, because we had a very high positive on the anode, like hundreds and hundreds of, or even thousands of volts. And that sort of cemented in your brain that the anode was always positive. So does a vacuum tube comply with the definition? Yep. Electrons are flowing out of the anode. So that's an active component. It's not a voltage source though. Neither was the LED. But they both complied with the anode rule. Let's keep going. Let's look at the anode of a battery or any other voltage source for that matter. So now we've got a battery. And finally, I've put anode and cathode on the battery. I was very frightened to do that earlier because I didn't want to give anyone, heart palpitations. But I think you're ready for it now. You're ready for it now. So I've put anode here, cathode. Now the anode of a battery is the negative terminal. Does it comply with the anode rule? Yes, electrons flow out of the anode. There's the anode of the battery. Electrons are flowing out. It's negative. Whoa. And around she goes. So that's that. Pretty simple. And I mean, with these voltages flipping around, there's got to be something consistent about the anode, surely. And there is. You get your trusty multimeter, or I don't think anyone's got standalone ammeters these days, but maybe. The anode always connects to the negative lead of the ammeter, always. Because electrons are coming out of that anode. This is just a voltmeter on this side. So just having a quick look here, positive here, electrons are being dragged out and they go in that circuit. And here, electrons are being ejected by the electromotive force of the battery out of the negative terminal, which is the anode, through the ammeter. So, yep. So whether you've got a passive component where you've got to apply voltage or an actual source, even though the polarities are reversed for these two, voltage-wise, current-wise, your ammeter is as shown up there. And that's it. That's all there is. Now, there is one more thing, and I'll let you do your own research on that, and that is, if it's a rechargeable battery, it gets even more strange, because what happens is when you're if a lead acid rechargeable battery discharges, that is the anode, that is the cathode. Everything's wonderful. But you have to realize that during charge, you're putting current into the anode. So if it's a rechargeable battery, it's a bit different, because what you'll find is you have to put current into this, therefore that can't be the anode. So when you charge a rechargeable battery, the anode and cathode actually reverse. All right, thanks very much everyone, and I'll see you next time.